So let's get started. Sorry about that interruption. So we're in our Schoology account. We're going to go to third period. And then on the home screen, I put a link here for you. All right. It's graphs and properties of logs. So if you haven't already clicked on that, if you haven't already found that, let's find that. Graphs and properties of logs. I would recommend that you go on over here and click the little box with the arrow so that we can get out of that tab. Takes us to a new tab. All right. And it works a lot easier when it's in its own tab. Okay? Go on and hit, when you get there, hit preview. All right? And this is where we're going to be. So if you want, hit the arrows there. You can go full screen. I'm going to kind of set this up first, all right, before we begin. Okay? And so we're going to do a little bit of exploration, see how some different changing of numbers is going to change our graphs today. So we're going to talk about log graphs. Last time before we were talking about exponents and properties of exponents. Kind of led us into some exponential equations, and we used our log graphs to do that. But our first little activity, excuse me, is we're going to look at this equation right here. We're going to do y equals log base b of x, all right? And what you're going to get a chance to do, the exploration you're doing, is you're going to be changing this base right there, okay? So the b is what's going to be changed. So when you put in different numbers, this is the value you're changing in the equation, and we're going to look and see how that changes on the graph. Everybody kind of understand what we're doing? So if I were to go back over here, go back full screen. So I'm going to get a chance to type in different values here. So I might type in a 2. We'll look and see what it looks like. I'm going to type in maybe a 4, maybe some fractions, some decimals, some zeros, some negative numbers. So it's your time to just kind of take a look and see how the graph changes. So I'm going to give you a little bit of time to do that. Okay? It's the very first one. Yep. You can go full screen that way. It's easier to see. So again, you're just kind of sampling, just kind of taking a look at a lot of different bases that it could be, looking to see what's going on there.
Is this in screens or?
Yeah, just go click that very first one. Yep. And you can full screen it right there. That way it's nice and easy to see, and you're just changing that value there.
I know it's a joke, so like, but no, it's weird. Yeah, that's weird. It's not funny. It's really
like
weird.
the Celtics
Okay.
Decimals, did you do zeros, did you do negatives?
Getting it.
Go down here and try to step go to Oh, click here, click the bottom of the arrow. It takes you to another screen. It'll be more popular.
No, they don't work. You have to lock
Hit OK here.
I'll wait.
And then hit, it's this very first one.
That would be kind of weird though. If,
And then go full screen.
what if you did like, you do that way, why do you like that? I know.
I'll understand that way.
All right.
But you,
So let's share out a little bit. Let's see what we've done. All right. And so anybody make an observation that you want to share with the class when we change different values up here? What observation did you see, or what's something that you did that kind of made the graph you look kind of unique? Anybody?
negative number.
Negative numbers. What about negative numbers?
It didn't appear.
it didn't appear. So if we put a negative base, it didn't appear, all right? I'm gonna come back to that here in a second. I'm gonna show you kind of why as far as an equation here in a second. In the back, what'd you say?
I said if the number is greater than 1, then it was a positive,
Okay, greater than 1 is positive. What do you mean by that?
like positive slope.
Okay, it's kind of got a positive, so if it's a bigger number, greater than 1, it's got a bigger slope, it's an increasing graph. Is probably what I would say, but I agree with you, that's a good point. Yes, sir?
Value 1 and 0, that show up as well.
Okay, the value between 1 and 0, is that what you said?
Yeah, 1 and 0 don't show up.
Okay, 1 and 0 don't show up at all, okay? All right, so no negatives, no 1s, no 0s, all right?
Whatever value you use that's positive, the y will equal 1 whenever the x is of that value.
Okay, is it just positives?
Haven't checked for decimals yet.
Okay, so let's go look at that. He said that the number, or the point 1, 0, which would be what specific point? What would we call that?
The intercept.
Yeah, the x-intercept, he said when they were all bigger than 1, they were all 1, 0. Is that true on the whole graph? What about decimals? Anybody try any decimals?
Yeah.
Mm-hmm. Yes, sir? Seems like it flipped the graph, okay? Yeah, flipped over the x-axis, yeah, okay? So, looks like we've got like a decreasing graph. It's going down now instead of going up. Good, all right? And I'm gonna put one of those in here just real quick. So 0.5, if I do that, and I go look, do I still have the same x-intercept?
Yeah.
Okay, so I do have the same x-intercept. So all my graphs have, it doesn't matter the base, all my graphs have the same x-intercept. It's 1, 0. All right? Anything from 0 to 1, it's a decreasing graph. Anything bigger than 1, it was an increasing graph. Anybody put a really big number in there?
I put like 1 trillion.
You put like 1 trillion in there? What did that graph look like?
It like made like a 90-degree.
It almost made like a 90-degree angle, okay? And so the bigger the number, the flatter the graph is that's going, all right? It's kind of going up and it flattens out really fast. It's not going up very quickly, okay? Good. Any other observations you make? There's a couple things I want to do. So I'm using page 8 right now, which should be a blank page for most of us in your book. So I'm using it just for you to take some notes along the way. So here's a couple little things that we noticed for this. We noticed that the point 1, 0 was on pretty much every graph. All right? The x-intercept 1, 0. Well, why is that true? Well, this x is 1, so log base b of 1. We talked about this property earlier in the year, all right? Didn't matter the base here. If I've got a 1 in that spot right there, the answer is always 0. Okay? So that's a really major log property. Okay? Now, if you were to look at this, we spent a lot of time before for the break, all right, before our last week, changing these from exponential to log. If I put this back in the exponential, this would be b, the y would be there, and the x would be here. B to the 0 power, anything to the 0 power is equal to 1. So that's what we're seeing there. Okay? Now, the other thing that you made mention of is you said that 0, 1, and negative numbers did not work as the base. What's the answer to 0 to the x? 0. It's always 0, right? So it's not going to give me one of these nice cool log graphs. It's just going to give me a straight line. So they didn't even show that on the graph. What about 1? It's just going to be 1, right? It's only going to be 1. It's going to be a horizontal line. It's not going to be much of a graph. Okay? And then the other one would be if we had a negative value in here. Let's say we have negative 2. Why do negatives not work? What happens if this exponent right there is an odd number? 1, 3, 5. The number stays negative. What happens if this exponent is an even?
It turns
Turns positive. So we go positive, negative, positive, negative, and this graph just zigzags back and forth. It doesn't look like the same graph we just had there. Okay? Everybody good? So those are some good pickups that you had there. Good observations as we're going. Now, the next. If you hit next, you go to slide 2. And before you start kind of playing around, let me give you a little introduction. All right? I'm going to give you a chance to kind of look at it here in a second.
So we need to answer questions.
You do not need to fill that in there. What I'd like for you to do is to fill in kind of what we're talking about on the screen. These go on page 8. That's probably more beneficial for you. Okay? So if you didn't get that last one, that's okay. But the next two are really important. Okay? So log base 2 of c to the x. So here's the premise on slide 2. Before you get to kind of exploring, this is what's going to take place. All right? So we're going to pick an easy base. We're going to pick the base 2. That's a nice easy base. We're going to say we're going to multiply it by c. So what you're going to change is this c value right there. Bless you. Okay? Before you do that, what does the c value do as far as transformations go on my graph? If I change that c value, how would I expect my graph to change? Say again? Vertical, why vertical?
Because it's next to the x.
It's next to the x, all right? But where else is it? Inside the parentheses. So I kind of get what you're saying there. But yeah, because it's inside parentheses, that's the biggest deal. So this is going to be some type of horizontal move. All right? What's the operation? C times x. So this is going to be a stretch or a compression. This is going to be a horizontal dilation. All right? So we should see the graph do something like this. From what it says here, this should be a horizontal dilation. All right, so here's what I want you to do. You're on slide 2 now. All right, so if we go to slide 2. All right, so slide 2. You have an opportunity now to take this C value and slide this C value and kind of slide it to some spots that look easier to kind of interpret and see if you can figure out what's going on with this graph. All right, so sliding your C value around. Stop it on some good points. Analyze those good points. All right. So as we've kind of slid this C value, we've changed it. Where were some good spots for you to stop with the C value? 16, 2.
1, 2, 4, 8, 16, and 32.
Okay, 1, 2, 4, 6, 8, 16 and 32. All right, so let's look at some of those. I'm going to go to 2 first. All right, and so when I go to 2, by the way, in general, how do you feel like this graph is moving? By changing the C value, right? We said it was supposed to do this. Is it doing this?
It's going up and
All right. It looks like it's going up and down. Now, a lot of times if you squeeze things like this, if you squeeze the ketchup bottle, all right, like this, what happens with the ketchup? It normally squirts out the top, right? So we kind of see kind of the same deal, but it's a little bit something different we're seeing as well. All right. So it looks like it's moving up and down, not horizontal. If it's 2, what looks like it's happened with my 2 points there?
And multiply the,
I added 1. So I was at 1, 0, and now I'm at 1, 1. Looks like I went up 1. I was at 2, 1. Now I'm at 2, 2. Looks like I went up 1. All right. You said something about multiplication. What are you multiplying? Yeah.
maybe your first, no, I don't know.
Not sure. Okay. So let's go to another one. Let's go to, I'm going to skip the 4. So if I have this one, I was at 1, 0, now I'm at 1, 2. What changed? The y value went up 2, went up 2 there as well. But that's 4. That's kind of weird, right? That was 4 and this is 2. This was 2. And that's 1. All right. The next one we said was 8. 8 was 3 and 3. Yes, sir?
What if it's the y value to the power of 2?
Y value and it's a power of 2.
Right.
All right. I think you're on kind of the right idea there. Yes, sir?
Every time the y value goes up 1, the c doubles.
Okay. Every time the y value goes up 1, the c doubles. Okay. So it's kind of exponential an idea. Good. All right. So realistically, if I were to go back to page 8, which that's kind of where I'm saying this is right here, by formula right here, it said horizontal dilation, but what we really saw was we saw a vertical shift. Okay? We saw a vertical shift is what we kind of saw. Now, real quick, did the shape of the graph change? It really didn't. Did it look like it was just being shifted upward? So the shape of the graph changed. Now, the shape of the graph, the parent function was log 2 of x. Log base 2 of x. That's the parent function. And what we were doing is we were adding a certain amount each time, and that certain amount was log base 2 of c. Okay? So here's what's taking place. The first one we came across was 2. We said c was 2. So if we do log base 2 of 2, what happens if those are the same number? You remember that property? It's 1. So when c was 2, everything went up 1. When it was 4, log base 2 of 4, that went up 2. Because what's the exponent that takes 2 and makes 4? 2 squared is 4. So that's 2. Log base 2 of c was 8. It went up, not 4, but 3. All right? So here's what we're doing. In this problem right here, c is a number. So log base 2 of c is a value. Now we picked all the easy values, correct? The ones that made it nice and pretty, that we went up 1, we went up 2, we went up 3, 4, so forth. And so what we have is we have a connection between this. This is what we said we were doing, but in actuality, this is kind of what the graph was doing. Everybody all right with that? Which means there must be a connection between these two things. This is a property of logs. Okay? Now let me ask this question. In exponents, this was on the test last week. If we had like bases and we were multiplying, what did we do with the exponents? We added them. Like bases and we were multiplying, we added. Well, guess what? If we're adding logs, what did we do with the x and the c here? We multiplied. Is that the same formula or is that the same property? Pretty much the same, but it's backwards, right? Okay? So if we're adding like bases, we multiply. Instead of multiplying like bases, we add. Because what are logs and exponents? They're inverses of each other. So guess what the properties are? Inverses of each other. All right? So that's what's taking place here. All right? We'll come back to that here in just a second. But that's kind of what we see happening on that one. All right? So we have one last one that we're gonna explore today. All right, this last one that we're gonna explore today is y equals log base 2 of x to the d value. So this is kind of the property that we're gonna look at, all right? All right, log base 2 of x to the d value. Now, let's discuss this before we kind of try it. It's going to be on slide 3, but before we try slide 3, all right, what do you think changing that d value, because that's what your slider is going to do, it's going to change that d value. How do you think changing this d value right here is going to change my graph? We had a transformation that looked like that. What do you think?
It makes the rate of change or whatever the word was exponential.
Okay, it looks like it's going to have some type of exponential effect on the rate of change.
Instead of the y is changing, the x is.
Okay, instead of the y is changing, the x is going to change, and they're going to change pretty quickly, maybe. All right, exponential is kind of weird. That's kind of weird to look at it like that, right? All right, so let's do this. I'm going to give you some time. All right, use the slider, find some good points, see if you can figure out kind of what's going on in that problem. So we're on slide 3, and you're sliding that d value. Find a couple good points, kind of figure out what's going on there.
Okay, good. I want you to make comment to that. Yeah, that's good, that's a good thing.
All right. So what were some good d values that you found that you liked that were easy to use?
2, 4, 8.
Any whole number, 2, 4, 8, any whole number, all right? Any whole number work good? So let's do this. I'm going to go to 2 on mine. So I'm going to set mine at 2, all right there. And so we said this was kind of a weird transformation. We think x is going to do something exponentially or whatever. What do you notice that's changing here? The y's, okay? And how are the y's changing here? I went from 2, 1 to 2, 2. I multiplied by the d value, okay? So 0.5 and -1 and 0.5 and -2. So I multiply by 2, looks good there. So it looks like what do we call that if we're multiplying the y value by a number? What transformation is that?
Dilation.
Vertical dilation, okay? So y values they're changing, all right? Now I'm gonna skip over here to 3. Same thing happened in 3. Does our conjecture still hold up there? Are we still multiplying by 3 on the y's? With all, technically, does it work with the decimals as well? Yeah, I just don't like messing with decimals, right? Okay, works with decimals. Now, what else did you notice?
It stayed at the 0.01.
They had a 0.01 or 10 that never changed. Anybody else notice that? It's like it's pivoting around this point right here. Why does 10 never change? Anything multiplied by 0 is 1. So I can multiply this 10 by anything and it doesn't ever change. That's how I know that this is more of a dilation than a shift. A while ago, all the points changed, correct? On this one, they're kind of spinning off of that one right there, okay? So now, let's go take a look at what's going on. And so we said here that log base 2 of x, that was our property, that was our parent function, okay? And what did we do with that parent function? How was it changing? What'd you tell me? You're multiplying everything by whatever the value was, correct? So this was like, this transformation, really weren't sure what was going on there. But this is a vertical dilation. This is vertical dilation right there. Now, so how do I get, again, we're connecting these two things. How do I get from this to this? What did I do? It looks like I kind of distributed. Kind of looks like I took this exponent that was up here, and we moved that exponent that was up here, and we moved it out front. Now, log is the answer to an exponent. So a log is an exponent. What happened when we took an exponent raised to an exponent? What properties of exponents? We multiplied them. Power to a power, we multiply. Well, guess what we're doing here? We've kind of got like a power to a power. So what do we do with that d value? We're multiplying. All right. Now, which one looks easier? Which one looks more easier to deal with? That second one looks a lot easier as we're going. Okay. So there's that multiplication that we're seeing, and so there's our properties of logs there. Okay. Everybody okay with that? All right. Here's what I want you to do. Turn to page 11. If you turn to page 11, it looks like this in your book. Okay? So what we've talked about today is we've talked about the first two of these three properties here. And so let's kind of generalize them. Let's write them out, kind of what we've seen. All right? So the first one was the product rule. We had log base b of cx, and we could rewrite that. That's product, c times x, and we can rewrite that log base b of c plus log base b of x. As long as the bases are the same, log base b and log base b, then we can split them. Now, sometimes we won't split them this way. Sometimes we'll use this right here and be able to simplify them and go that way. So if I see like bases and I'm adding, then I can take the c and the x and multiply them together and put them together into one logarithm. Okay? So, if I were to do this right here, if I were to do log base 2 of 3 plus log base 2 of 12. So log base 2 of 3 plus log base 2 of 12. Could I simplify that? Do they have the same basis? They do. Log base 3. All right, excuse me, log base 2. And then I can put these together by saying log base 2 of what?
36.
Of 36. Okay? What do we do with the 3 and the 12? We multiply those. Okay? Log base 2 of 36. Now that doesn't work, all right? Or it's not, doesn't come out evenly, so we need to use our calculator probably to help us with that. But at least we can only put one thing in there instead of both. Okay? So that's how that property kind of works. Now, the other property. The power rule is the other one that we discussed today. So the power rule is log base b of x to the d power. And we could simplify it, or we could rearrange it by doing what? Taking the d and multiplying it out front. Yep. Log base b of x. So those two things are the same there. And we could go back and forth. We could put the d there. We could put it back if we need to. But here's an example of one we could do. Okay? Log base 2 of 4 to the 6. Now, you got a calculator, not a big deal, right? But if you don't have a calculator, it's just kind of a big deal. How many of you want to do 4 to the 6th power? No thank you. Okay? So what does our property tell us we can do? Take the 6, making a multiplication by moving the 6 out front and doing a log base to 4. Now, we've already seen this once today. Log base 2 of 4. Everybody remember what that is? That's 2. What's the exponent? Again, remember, logs are the answer to an exponent. What exponent takes 2 and makes 4? 2 squared. So in the box here is 2 times 6 is 12. So that answer is 12. I could use my properties of exponents to get there. Okay? Now, guess what? If you typed all that into the calculator, you'd get 12. You'd be good. Okay? All right. So here's what I'd like for you to do. This is classwork finishing up today. We kind of finished a little bit early. That's okay. All right. I want you to look at problem 2, same page, page 11, problem 2, and I want you to work question B and question D. All right. Now here's what it asks you to do. It asks you to tell me if that's a true or false statement. All right. But I'm going to add to it a little bit. If it's a false statement, I want you to fix it so that it's true. Okay? So you're just doing B and D for the day. All right? All right, so looking at them and seeing if they're true or false. And if it's false, then change it to make it true. Okay? And that's how we're going to finish. We've got about 9 minutes left. And so we'll be there done with that for the day.